6.3, we're going to deal with area of circles. So the circumference of a circle is 2 pi r or pi d. The area of a circle is pi r squared. How do you remember that? Well, a circumference could be in inches or centimeters or miles, but an area would be inches squared, centimeters squared, and miles squared. And this is the only one that squares our unit portion of the equation. So the r squared equation has to be the area because we need units squared. So, oh, sorry, didn't pull it over. Area involving circles and rectangles. So I essentially here have a circle whose radius is 34. That would be this piece and this piece. So pi times 34 squared. And then the area of the rectangle is simply 94 times 68. Now it wants you to use 3.14 for pi, and actually that's all you really need. How many values of pi does NASA use? You know, they're flying around the solar system. I think they use 8 or 9. If you wanted, so how big is the universe? We're assuming infinite. We don't know. We can't see the end of it, right? So the observable universe is as far as we can see. How far away is that? It's like 34 billion light years, which is insanely far. Now, why is it that far away? Why can't we see any farther than that? Well, it takes time for light to travel. So that light from the other side of that line just hasn't got here yet. So every day we can see a little bit farther. Okay, so let's say you are standing on one side of the observable universe and you wanted to hit a hydrogen atom, which is just a proton. You wanted to draw a circle, and you wanted that circle to be accurate enough to hit that proton. You only need 39 decimals of pi. How many decimals of pi do we know? Into the trillions. Last I checked, it was like 62.8 trillion places. Yeah. We don't need that many. Okay. Next. All right. Area of a sector. Okay. A sector is basically a piece of pizza. So if you take a circle and you draw lines from the circle to the center, 2 of them, then you create a circle sector. So here we have kind of a big piece of pizza, but really we have 2 pieces of pizza, right? We sort of have the inner pizza right here, and then the outer pizza, the big one and the small one. So we know that the area of the circle is pi times 4 squared. And we know that the central angle is 110 degrees. So what is the area of our piece of pizza? Well, how much of the circle does that pizza represent? It is 110 degrees out of a total of 360 degrees. And that gives me, that simplifies down to 11 over 36, which is 30.5%. Okay? So, well, it wants an exact answer, so we're going to do 11 over 36. So this is the area of the entire circle, and this is the percentage of our piece of pizza. So we just multiply those together, and I get 11 pi times 4 squared over 36. And one of the 4's turns the 36 into a 9. So I get 44 pi over 9. And then this is in inches squared. And this time it doesn't want the decimal answer. It wants what's called the exact answer. All right, let's do another one of those. All right. So the radius is 5 and the angle is 40. So the area of the circle is pi times 5 squared, so 25 pi. And our piece of pizza has a 40-degree angle. So 40 divided by 360 is going to be, zeros cancel, 4 over 36 is 1/9. So our pizza is 1/9 of the full circle. So I times this by 1/9, and I get 25 pi over 9 centimeters squared. Easy enough? All right. At the park, there's a pool shaped like a circle. A ring-shaped path goes around the pool. They're going to put a new layer of coating on the path. 1 gallon can cover 8 yards squared. How many gallons of coating do they need? So the big circle has an area of pi times 9 squared. The small circle has an area of pi times 6 squared. Okay, so 3.14 times 9 squared is 254.35 yards squared. And then 3.14 times 6 squared is 113.04 yards squared. So the path is simply the difference between those two areas. So 254.34 minus 113.04 is 141.3 yards squared. Okay. So I now know the area of the path. How do I figure out how many gallons it takes? So we have 8 yards per gallon, or also known as 1 gallon will cover yards squared. Yards squared. So I times this by 1 gallon over 8 yards squared. The yard squared cancels the yard squared. Divide by 8. And this is a little tricky. I get 17.6. So how many gallons of paint do I need? 18. They won't let you buy 2/3 of a gallon. So this will take 18 gallons. It won't take 18 gallons, but you're going to have to buy 18 gallons. That's why it says the number of gallons must be a whole number. All right. Find the area of the shaded region. Okay. Well, it only gives me one measurement, 16. But if these are semicircles, then this point here is directly in the middle, which means the diameter of this circle is 8, which means the radius of the circle is 4, which means this length here is a 4. So the entire figure has an area of 16 times 4. So 64 meters squared. And then really we just have a single circle with a radius of 4. So the area of the circle is pi times 4 squared. And then you're just going to subtract from 64. So 64 minus 3.14 times 4 squared. And I get 13.76 meters square. That one's pretty straightforward. Okay, arc length. So arc length is how long is the crust on your pizza? So in mathematics, whenever you hear the word arc is not just any semi-curved shape. An arc is defined as a piece of a circle. So arc length would be how long is the crust of your pizza. So we already did area of a sector. How much area does your piece of pizza have? Arc length is going to be how far is it from A to B. So if r equals 3, the circumference of this circle is 2 times pi times 3. So we'll just say 6 pi. Okay? And the angle AOB is 120. So we need to figure out what percentage of the circle that angle takes up. So 120 out of 360 simplifies down to 1/3. So our arc length is going to be 1/3 of this, which ends up being 2 pi. So the arc length is 2 pi. Okay. What about the area of that section? Well, the entire area of the circle is going to be pi times 3 squared, or 9 pi yards squared. And we know that this pizza is 1/3 of the entire pizza. So we times this by 1/3, and we get 3 pi yards squared. All right. Oh, make sure you put yards and yards squared. Okay. And I believe this is the, oh, that was the last one. All right. That's it. Get to work.